Lesson 5.6 is on graphing linear inequalities with two variables. Pretty much what that boils down to is we have y equals mx plus b as an equation, but instead of the equal sign, we trade it out for one of the four inequality symbols. So this greater than means we would graph the line, but then we would shade anything bigger than the line. So basically shade above the line. I'll make a side note about that later when we start getting these actually on a graph. So a solution for one of these linear inequalities is just an ordered pair that makes the inequality true. So let's check if this point is a solution to this inequality. I would plug in my x and my y from the ordered pair into the x and the y in the equation. 2 times -1 is -2. -2 plus 9 is 7. So I end up with 7 less than -3. Well, that's false, so it's not a solution. Here's another one. Plug in my ordered pair as the x and the y. -3 times -2 is +6. 2 plus 6 is 8. 8 greater than or equal to 8? Well, because we have the or equal to sign, that one works. So it's true. We would call that a solution. So finally, we get to graphing inequalities. We'll start with a simple one. So the first question we ask ourselves is, we have dashed or solid lines? All right, dashed is when we don't have the or equal to symbol. Solid is when we do have the or equal to symbol. So in other words, solid means the line itself counts. Dashed means it doesn't. So ours is going to be solid for this problem. And then y less than or equal to 2. Shade above or below. Well, we want the stuff less than or equal to 2. The smaller stuff is below the line, because that would be shading down towards the negatives. So there are two extra questions we have to ask ourselves besides our normal graphing skills. So the line y equals 2 is kind of what we're graphing. And we'll make that a solid line, and then we'll shade below that line. Now y equals 2 is a horizontal line at 2, because any of these points should have 2 as their y. Basically what that means is x can be anything, but y has to be 2. All right, so that's how I know it's a horizontal line. Another way to think of it is this could be plus 0x, so it would have a slope of 0. But that's our line, and then we're supposed to shade below it. So when I just have one line like this to shade, I just kind of squiggle across. I don't have to shade the whole thing in all nice and pretty. Just need to show which side of the line should count. So anything down here is a solution. Anything above it is not. And hopefully that makes sense, because if I'm down here, my y coordinate is going to be negative. And of course, a negative number is smaller than 2. But if I'm above the line, like up here, well, my y coordinate would be 4. 4 is not less than or equal to 2. So that's what the shading is for on this graph. Here we've got another one. We are going to want to get this equation into slope-intercept form before we graph it. We could graph it using the intercepts, but I think this is what most of us are more comfortable with. So I added x on both sides, and then I'm going to divide by 2. X over 2 is 1/2 x. And there. These are the same equation. This one is just nicer for me to look at for graphing purposes. All right, let's ask ourselves those two questions that are important for inequalities. Dashed your solid line. This one is going to be dashed because of the no or equal to line. And then we're going to shade above because we want the y values bigger than the graph. Now, how do I know I'm comparing the y instead of the x? We compare the variable that's alone. So there might be some equations for vertical lines where it's just like x greater than 5. That would be a vertical line at 5 where we shade to the right. So we don't run into that very often. But when you have a vertical line, you think in terms of left or right instead of above or below. That's just one special case here. All right, so y-intercept, start up 1. Slope of 1/2, that's up 1, right 2. Up 1, right 2. You can add more points by going down and left. And now it should be a dashed line. And that's our way of saying the line doesn't actually count. Then we shade above the graph, and that's our graphed inequality. One thing just to reinforce what we started the lesson with is if I take an ordered pair that's in the shaded area and plug it into my equation, it should make the inequality true. So this is the point -1, 3. Let's just try plugging that in quick. All right, so my original equation, I would have -x, so -1, plus 2 times y, 2 times 3, is greater than 2. -1 is 1, 2 times 3 is 6, 1 plus 6 is 7. Of course, 7 is greater than 2. So anything in the shaded area should be a point that makes our inequality true.